Okay, in this video I'm going to do some examples of number conversion, and this is very much like some of the problems in your homework, and I'll review for you some techniques of doing this. The first one is asking you to do decimal to binary conversion, and we're going to take 225 as a decimal and convert it to binary. The easiest way to do this is to simply look at whether or not it's even or odd. And if it's odd, what we're going to say is that the least significant bit of the binary representation must be a 1. And if it's odd, we're going to subtract 1 and divide in half now. So 224 is 225 minus 1. We divide in half, we get 112. 112 is even, so we're going to write down a 0. Now, because it's even, we divide it in half again. We get 56. That's even, so we write a 0. Whoa, what was that? 56 divided in half is 28. This thing, how do I avoid this? 28. And that's even. Now we divide in half again. 14, that's even, so we write another 0. Divide in half again. 7 is odd, so we write a 1. Now we subtract 1 and get a 6. That divided in half is 3, which is odd. We get a 1. Now we subtract 1, divide in half, we get a 1, and that is odd, and we get a 1. And now what we do is we take all these zeros and ones that we've created over here and put them in reverse order, so that we have a 1, 1, 1, 0, 0, 0, 0, 1. Okay, 4 zeros and then that last one. Right. So we're going to take them in reverse order. And now this is our binary representation of 225. Let's double check that. This is the 120, let's see, the places here go from 1, 2, 4, 8, 16, 32, 64, 128's place. So we have a 1 in the 128's place, we have a 1 in the 64's place, we have a 1 in the 32's place, and then we don't have anything in the 16's, 8's, 4's, 2's, but we have a 1 in the 1's place. And now we add these up, 12, 14, 15, carry the 1, 10, 12, 225, and we've got a successful conversion, okay? And this is a very powerful algorithm for converting from decimal into binary. Again, you see whether the number is odd or even. If it's odd, you put a 1 and subtract 1 from it. If it's even, you put a 0, and then you divide by 2 and repeat until you get to a 1 at the end. And when you try to divide the 1 by 2, you get a 1/2, which means that you have zeros from there on out in your binary representation. Okay, so we've done it and we've checked it. Let's go ahead and convert in problem 2 from binary to decimal. Okay, this is 0, 1, 0, 1, 0, 1, 0, 1. Let me write that out a little bit larger. And we can see that we have a 1 in the 64's place, a 0 in the 32's, but a 1 in the 16, a 0 in the 8, but a 1 in the 4, a 0 in the 2, but a 1 in the 1. And we add these up, 10, 15, 85. And so 0, 1, 0, 1, 0, 1, 0, 1 binary is equal to 85 in decimal. Okay? Hex conversions are a little bit different. Let's see if I can push this up here. Hex conversions, when you go to and from hex, it's much easier to go to binary first. And when you go to binary, you group them in groups of 4, and you will get hex digits. I'll show you how that works. I'm going to put the 200 into binary first. I'm going to get a 0 because it's even. 100. When I divide by 2, I get a 0 because 100 is even. divide by 2, I get 50. A 0 because that's even. 25, I get a 1 because that's odd. I subtract 1 to 24 and divide by 2 to get 12. That's even. 6 is even. 3 is odd. Subtract 1 and divide by 2. You got to be careful here. So 3 minus 1 is 2. Divided by 2 is 1. And that's that last 1. And so we have 1, 1, 0, 0, 1, 0, 0, 0. And that's supposed to be 200. Let's quickly check that. We have a 1 in the 128's place, a 1 in the 64's place, and a 1 in the 16's place. 12, 18, 6, and 4 is 10, and a 2. What did I do wrong? 1, 2, 4, 8. This is the 1, 2, 4, 8's place, not the 16's place. 128, 64, and 8 is what I'm supposed to be adding here. 12, 20, 6 and 4 is 10, 200. Okay, now it checks. Okay, now to go from binary to hex is very easy. You just group them into groups of 4. And this is an 8, and this is an 8 plus a 4, which is a 12, which is really 10, 11, 12, A, B, C. It's really a C8, in other words, okay? So in hex, a C8 is equal to 200 in decimal, okay? And that's a very good trick for hex. You always just go to binary first and then group them in groups of 4 for hex. If you group them in groups of 3, you'll get octal. Okay? Okay, so here we have 2b hexadecimal. That's pretty straightforward. In hex, we have the 1's place, we have the 16's place, we have the 256's place, and 2 times 2 in the 16's place gives me 2 times 16 plus a b in the 1's place gives me an 11. 32 plus 11 is 43. And so 2b hex is 43 decimal. 2b hex. Okay, hope this helps.